So hi, for today we would like to present to you about optimization of rectangle. Our class is AS120 and our lecturer name is Madam Amirahana binti Muhammad Noor. So first, I would like to introduce to you about our group member. First is Wana Shakira binti Wan Zainal Abidin. Second is Nurin Patricia binti Kamaruddin, and lastly is me, and Ashikin binti Asmawi.
Optimization is the process of finding the maximum or minimum values. A practical example would be minimizing the cost of producing an automobile in light of certain non-constraints on the cost of each part and the time spent by each laborer, all which may be interdependent. Regardless of the application, the most important step in addressing a maximum or minimum issue is to represent it mathematically. Hi, Assalamualaikum. My name is Wana Shakira from class AS120 Today, I want to explain about rectangular question. The question is a shepherd wants to build a rectangular sheepfold with 3 parallel partitions using 500 ft of fencing. So the total area of the sheepfold is 250 x minus 5/2 x squared. The first one, we have to identify the vertical, which is x, and horizontal, which is y, in the figure above. The variable is depend on the figure given. Step 2, we can build a formula from that given shape. The x have 5x and y has 2y. So the formula is x plus x plus x plus y plus x plus x plus y equal to 500 from the question that I have built. After that, we will get the formula, which is 5x plus 2y equal to 500. We have to solve that formula until get the value of y, which is 2y equal to 500 and minus 5x, because positive 5x move to right will be negative, and then we will get the value y equal to 250 minus 5x over 2. So this is our equation 1. Step 3 is we have only variable, so we can use the equation A equal to y times x, so we will get the equation 2, which is xy. Then step 4, we will substitute equation 1 into equation 2. So the formula is A equal to x times 250 minus 5/2x. Then we will get the answer 250x minus 5/2x squared.
So for the second question is find the dimension that will maximize the total area of the sheepfold. Hence, determine the maximum area of the sheepfold. Okay, first we need to differentiate the equation that have been stated above, which is from the equation above. We also can take it from the answer from the previous slide. Okay, so we need to differentiate, refer on the symbol used in the equation, which is dA over dx. Okay, first we need to find a dA over dx from A, which is 250x minus 5/2 x squared, need to be differentiated. So it will be 250 minus 5x. So after that, when dA over dx is equal to 0, 250 minus 5x equal to 0. So we need to calculate it using a mathematical formula and step. So the answer of x is 50 cm.
To find the second derivative of a with respect to x, we start from the given first derivative. dA over dx equal to 250 minus 5x. Then we need to find the second derivative. d squared a over dx squared equal to d over dx times with 250 minus 5x. Since 250 is a constant and its derivative is 0, and derivative of negative 5x is negative 5, we have d squared a over dx squared equal to negative 5. Given that d squared a over dx squared equal to negative 5 is less than 0, this indicates that the function ax has a maximum point, since the second derivative test show that if the second derivative is negative, the function has a maximum. After that, we substitute the value of x that we get from the previous slide, which is 50. So the equation will be 250 minus 5 over 2 times with 50, and we get 125. The value of x will be 50 feet that will maximize the area. Now, substituting the value of x, which is 50, back into the equation for A to find the maximum area. So A equal to 250x minus 5 over 2x square, and substituting x equal to 50. The equation will be A equal to 250 times with 50 minus 5 over 2 times with 50 square, and we put the equation in the calculator and get 6,250 feet square. Lastly, the value of x will be 50 feet while the value of y will be 6,250 feet square. Lastly, for the conclusion, the first one, we must draw and label the following problems and determine whether they are minimized or maximized. The second one, solve the problem by using the first and second derivative method. The third point is put the variable in the equation. And the last one, ensure that you re-verify the step and your solution.